In this quiet suburban house exists a misfit group of superheroes called
You can't act. What the heck is Bumblebee doing? I'm gonna go find out. What are you doing?
Improbables. I got Bumblebee. Something's wrong with his memory. I'm taking him back to the base.
Yep, there's something wrong with him, alright. Guys, Bumblebee's scan is complete. Missing data. Chapter 9. Section 9.1, Introduction to Probability. Section 9.2, Theoretical Probability. And Section 9.3, Experimental Probability. We might have to teach him all of this. Hey Bumblebee, watch this to learn probability.
Hello everybody, and today I'm going to introduce you to probability, and we're going to identify outcomes. So, we're going to be looking at a die here, and we'll look at the favorable outcomes of rolling an odd and an even number. So the odd numbers, as you can see, if you can see it, well there's a 1 right here, so we got a 1, a 3, and a 5. And then the even numbers, we got a 2, a 4, and a 6. Alright? Now, the number of possibilities is 6, odd and even. Mixed together, we get 6 total. So then we got 3 odd numbers and 3 even numbers. And then we have to put the 3 on top of the 6, and that's 1/2. And that is the favorable outcomes of rolling an odd number or an even number.
Theoretical probability
is the likeliness of
An event occurring based on all the
possible outcomes.
Hello, and today we are going to be doing the second section called Theoretical Probability. And we are going to be finding theoretical probability. So, we are looking at this coin. We are pretty much looking at all these items today. And there's a theoretical probability of flipping heads or tails. Now, when you look at the favorable outcomes, you got 2 different outcomes. We got heads or tails. And then the possible outcomes would be 2. So that would be 1 out of 2 for flipping a heads or a tails. So we got heads, and so that's 1 out of 2. Now on the die, rolling a 1, we would get 1 out of 6, because the 1 is the favorable outcomes, or we got 1 for the favorable outcomes, and then the possible outcomes would be 6, 1 out of the whole thing. Now a spinner, when you look at the spinner, for spinning a 2, you would spin it and get a 2. That would be 1 out of 10, because the possible outcomes would be 10. So, today we will be doing theoretical probability. Now, what is the theoretical probability of grabbing a yellow brick from the bag? Now, the total number of bricks is 20, and there are 4 yellow bricks, so it's 4 over 20.
Experimental probability
is the ratio of the
numbers of times an event occurs to the total
number of times the
activity is performed.
This is an example of experimental probability. What is the probability of flipping heads, and what is the probability of flipping tails using this coin? That was my 50th flip. I got 29 heads and 21 tails.
Alright, now that we flipped the coin, now we're going to compare theoretical probability and experimental probability. Now, theoretical probability is what's supposed to happen. So, when we flipped the coin, what was supposed to happen was 25 tails and 25 heads out of the 50 flips I did. Now, that is theoretical probability. Now, experimental probability is when you do it, which we did, and we got 21 tails and 29 heads. So that is experimental probability, which is when you actually do it. And you're not going to get the same thing, but they are very similar.
Okay, Bumblebee, hopefully you learned something from this classic video on probability. Now let's go test your skills.
What's the possible outcome of getting a 2 on that spinner?
1 in 21.
Woo! Yeah, got a 2. Yeah.
Guys, not in the house.
Sorry! What is the probability of Michael Jackson rolling a 1?
1 in 4.
One.
Guys!
Sorry!
What's the probability of you getting an orange? You got it!
We're going to Mickey D!
Guys, listen to your mom.
Okay.
No, I did it wrong. 1, 2, 3. I did it wrong. 1, 2, 3.
What's the probability of Michael Jackson?
Why can't you finish it?
Happy honeymoon!
I think that's the right name. Hi. Sergeant Mufflebuns is here. He's gonna save the day.
Go. Okay, so all you're gonna say, that's right. And everybody celebrates. Go.
That's right.
That's right!